Hello, PreCalc. We're going to work on Ingenuity Section 9.2, Geometric Sequences. We've got 4 objectives for this. The first is to find the common ratio of a geometric sequence. The second is to determine if a sequence is geometric, to apply the formula of a geometric sequence, and to find terms of a geometric sequence. So let's take a look at some problems to help us with that. So describe the characteristics of a geometric sequence. The main, most important characteristic of a geometric sequence is that it has what they call a common ratio. And all that means is that you multiply the same number over and over to get the next number. So that's all it means, is we're just going to keep multiplying by the same number again and again and again. Now, sometimes that number will be a fraction. Sometimes it won't, but we're just going to keep multiplying by the same number. If you find that you can divide by the same number, that's multiplying by 1 over that number. If I'm dividing by 6 over and over again to get the next number and the next number, one of the ways you can think of that is that I'm multiplying by 1 over 6 over and over and over again. So let's look. I'll give you a chance to process that for a moment. And let's look at the next one. All right, let's look at this problem. The first 4 terms of a geometric sequence are 108, 36, 12, 4. What is the common ratio? So what's really important is they've already told me it's a geometric sequence, right? So the question is, what am I multiplying by to get the next number, the next number, the next number, the next number? And again, I like to look at like the simplest one. You're just going to divide or multiply by something to get the next one and the next one. So if you look at these two, those two are pretty easy to figure out. How did I go from 12 to 4? Well, I divided by 3, right? But that's not the common ratio. If you divide by 3, then the common ratio is 1/3. That is, I multiplied to go from 108 to 36, I multiplied by 1/3. To go from 36 to 12, I multiplied by 1/3. To go from 12 to 4, I multiplied by 1/3. So the common ratio is 1 over 3. That is, I keep multiplying by 1/3, dividing by 3. Remember, the definition of division is that it is multiplication by reciprocal. So if I say I'm dividing by 3 each time, I mean I'm multiplying by the reciprocal of 3. That is 1 over 3. Okay, so there's my common ratio. I'll let you look at that for a moment. And let's look at the next problem. All right, the fish population in a lake decreases by 2% each year. What is the common ratio? So let's think about this in the easiest way that we can. If you're talking percents, the easiest way to think about things is, let's think about 100 first, okay? If I started with 100 of them, or 100% of them, or however you want to think of it, and I decrease by 2%, what is that? Well, that's 98%, right? And then I would be doing 98% of that 98, right? And then I'd get an answer for that and take 98% of that and over again. With percents, the word of means multiply. So if I'm decreasing by 2%, I'm getting 98% of the thing each time. So what is my common ratio? My common ratio is 98%, or 0.98. Remember, to go from percent to decimal, you find the decimal in the percent and go 2 places smaller. Okay, so that's how we go from 98% to 0.98, and so our common ratio is 0.98. I'll give you a moment to look at that, see if there are any questions. All right, let's go on to the next problem. All right, again, we're given a geometric sequence, so we're being told already that it is a geometric sequence. And here's the first 3 numbers, and it wants to know what's the next term. So how do we get the next term? Well, let's take a look here. If I do negative 880 divided by 220, and I just do the division there, one way to do that division is I can reduce them both by 10, and then negative divided by negative is positive, and 88 divided by 22 is 4. And you can check that. We can do 220 over 55. Negative divided by negative is positive, so I won't put the negative again. But if you do that division again, you could, I don't know, you could reduce them by 5. That's pretty easy. 5 divided by 220 is, well, or 220 divided by 5, I'm sorry. 220 divided by 5 is 4. Carry the 2 is 4, so it's 44. Over 55 divided by 5 is 11, which is also, of course, 4. So, and I didn't really need to do that second one. I just thought it might be good to double check, show you that it works each time. But, so when I divide each thing, I get 4. But notice that when I move from one to the next, I'm actually going down. So my common ratio, the thing that I keep multiplying by, is 1/4, right? To go from one to the next, I need to multiply by 1/4. So I just need to do negative 55 times 1/4 to get the next term. So negative times positive is negative. And then take this, multiply, well, I guess just the number, because we are already dealt with the negative. Multiply it by the top only, and I get 55 over 4, so negative 55 over 4 is my next term. I'll pause for a moment, let you look at that. And let's go on to the next problem. All right, so now let's talk about the 700th term of a geometric sequence, and we're told that it's 20. Okay, so we got a whole bunch of them, and we go up to, we get to the 699th term, and then the 700th term is 20. If the common ratio is 0.25, what is the 699th term? I really don't like this being 0.25, but whatever, we can deal with it. What that means is if I divided these two, this one divided by that one in that order, I would get 0.25, or 1/4, right? So what this really tells me, and I think it'll make a little more sense if we think of it this way. The common ratio is 1/4. So to go from this one to that one, I multiplied by 1/4. So to go the other way, I just need to multiply by 4, right? So to go from here to here, I'll multiply by 4. And so that'll be 20 times 4 is 80. And so this one should be 80 because if I do 80 times 0.25 or 1/4, I get 20, right? So that is the 699th term. I'll pause for a moment, let you get a look at that. All right, let's look at the next problem. All right, a sequence is defined by the first term equaling 6, and every next term being gotten by multiplying the previous term by -1.2. What is the fourth term? So we've got 6, and then if I do 6 times -1.2, that'll get me the next one. So negative or positive times negative is a negative, and then 1.2 times 6. 6 times 2 is 12, carry the 1, 6 times 1 is 6, plus 1 is 7, 1 decimal place, so this is -7.2, and then multiply by -1.2 again, so -7.2 times -1.2, negative times negative is positive, and multiply by 1.2 again, and 2 times 2 is 4, 2 times 7 is 14, 0 placeholder, 1 times 2 is 2, 1 times 7 is 7, add them together, and you get 4, 6, and 8, 2 decimal places, so we get 8.64. And then the next one will give me my fourth term. So I just got to multiply by -1.2 again. A positive times negative is a negative. And multiply by 1.2. That'll be 8. And 2 times 6 is 12. Carry the 1. 16, 17. 0 placeholder. And then 4, 6, 8. Add them together and I get 8. 6, 13, carry the 1, 10, and 1, 2, 3 decimal places, so this is -10.368. And there's my fourth term, so my A sub 4 equals -10.368. All right. I'll give you a moment to look at that. All right, let's move on to the next one. A sequence is defined, and these are all geometric sequences, by the way. A sequence is defined by a sub n equals 4 raised to the n minus 1 power. What is a sub 1? What is a sub 8? So the first term and the 8th term. Now, this is really convenient. Again, this is one of those things where we don't need almost any information, right? A sub 1 means replacing the n with a 1, that also means replacing that n with a 1, so it's 4 raised to the 1 minus 1, which is 4 raised to the 0, and anything other than 0 raised to the 0 power is 1. So the first term is 1. The 8th term is 4 raised to the 8 minus 1, so 4 to the 7th, and you could use a calculator and figure out what 4 to the 7th is. It's some giant number that I'm not going to bother with right now. You can put that into a calculator if you really need to. What is important here is that we have a rule now that will allow us to write a general equation for any of them, right? And we're going to have to come back to that. So write the formula for the nth term. So we want to go back to this formula for the nth term. So we want an a sub n equals, and what we didn't see in this one but is really important is that there's a 1 times there, okay? So in this type of formula, the way this works is you say a sub n equals a sub 1 times, and if you use this is the common ratio, times the common ratio raised to the n minus 1, and that'll give you the formula for the nth term. So let's try and put some of that in, okay? Again, what's the common ratio? Well, let's look at the easiest thing, how to get from one to the next one. And for me, I'd look at these two as the easiest, okay? To go from -2 to 6, that common ratio, -2 times what equals 6? Well, -3, right? And what's our first term? Well, it's staring right at us. It's -2 over 9. So really, that's all we need to put this into place, right? A sub n equals the first term, -2 over 9, times the common ratio, -3, raised to the n minus 1 power. And there we have it. Let's check it just to be sure, but you'll see that it is true. Let's get the third term. That would be, we should be looking to get -2, right? So that's -2/9 times -3 raised to the 3 minus 1. Notice n and n are being replaced by 3 and 3, right? So that's going to give me -2/9 times -3 to the 2nd, which is -2/9, times -3 to the 2nd. -3 squared means -3 times -3 again. Negative times a negative is a positive. 3 times 3 is 9. Well, that's convenient because 9 over 9 cancels. Let me be a little more careful about that, which is to say, I take this one, I multiply it to the top only. So I could think of this as having -2 times 9 over 9, and 9 over 9 is 1, so they cancel, leaving me with just -2, which is, of course, what I was looking for. All right. Well, thank you so much. That is the end of this one. I'll give you a moment to look at that, and then I'll stop the recording.